Recording in progress.
Hi students, in the last lecture we have discussed what is a dipole and what is dipole moment vector, right? Then we made calculation for torque, potential energy, and finally we made calculation for time period of small oscillations, right? That is what we have discussed. Now in this lecture we are going to discuss electric field due to dipole. So we calculate on axial line. So we are calculating on axial line. Axial line means it is a line joining both the charges. Axial line. Second one on perpendicular bisector. Okay. And finally it is at a general point. See how we make calculation for these things. First axial line. Okay. Right. So we are taking now axial line. Let us take two charges which are having same magnitude but different signs. It is minus q. Other one is plus q. Let us take now separation between them. That is now 2n. How much? I am taking separation between them as 2n. Okay. This is minus q and this is plus q. Okay. Right. We want to calculate at a point on the axial line. Suppose at this point, at a point P, we want to calculate electric field. Okay. Its distance, its distance from midpoint of dipole. So take it as it is R. Okay. So we have taken a dipole minus q plus 2. Separation is 2L. We want to calculate now on axial line at a point. Distance is R from midpoint. Okay. So it is now simply calculating electric field due to each charge separately because of minus q and because of plus q. Okay. Right. See what is now net field. So first one, whenever we want to calculate strength of the field, we have to imagine there is a unit positive charge, right? So step one, imagine their unit positive charge, right? If you observe this positive charge repelling this positive charge, so direction is right side. This negative charge attracting positive charge left side. But we can say directly here repulsion will be dominating. That means direction of the field will be right side. Okay, right. So that net value how much? So it is now E equal to because of positive charge, what I can write here K Q means K into Q1 Q2. Okay, Q1 is 1, Q2 value Q. K into Q1 Q2 by R square. Distance how much? Distance is now R minus L and R square of that. Okay. Minus. See, this is now field because of the positive charge. Let us take now field due to negative charge. Field due to negative charge. That is KQ. Why I am taking minus here? Because direction is now, it is left side. Because of positive charge right side, because of negative charge left side. Okay, K into Q Distance will be r plus L and square of that. And remember just a calculation part. See what we get. K, Q. Remaining is now 1 by r minus L whole square minus 1 by r plus L whole square. What we can say here? A plus B whole square minus A minus B whole square, right? That becomes now 4AB, right? K, Q. It becomes a 4AB, right? This is now what I can write. R square minus L square whole square, right? That is equal to, see what we can write here. If we assume that L value very small compared to R, if we assume that L value very small compared to R, then L square will be smaller than R square. So we can neglect now this L square when compared to R square. Reason is that dipole means between the charges separation will be very small. Already we have seen like examples, common salt, NaCl, right? Na plus Cl minus, or if you take H2O, right? So we have seen between those atoms, separation is very small. Therefore, this becomes now, I am writing here Q into 2L as P, okay? Q into 2L as P. 1 R, here R power 4, remaining is now 2K P by RQ. See carefully what I have taken. I have taken Q into 2L. This is a 4L. I have taken 2L, that is a P. Remaining 2 I have taken here. So it is a 2Kp by R cube. And what the K means? It is 1 by 4 pi epsilon naught. Okay, right. And if you want this in vector form, if you want in vector form, this can be written as, this can be written as, this can be written as E bar equal to 2K P bar by R cube. That means when we are taking electric field on the axial line of a dipole, direction of E bar will be direction of P bar. See carefully, positive repelling positive, negative attracting, but here positive is now dominating. That's why net is right side. Direction of P bar, negative to positive. It is negative to positive, means right side. Okay. So direction of E bar is direction of P bar. Suppose if you take this point left of minus Q, if anybody getting doubt like if I am taking left of minus Q, what happens? Remains the same value, same direction. See carefully. If you take here, what happens is attraction dominates. Since it is a closer to minus Q, attraction dominates. Attraction means it is the right side. Repulsion bias 1, it is left side. Means again net value is now right side. Right side means minus Q2 plus Q. That means whether we take right of plus Q or left of minus Q, in both cases, direction of E bar is along the direction of P bar. Okay, right. Let us now consider on perpendicular bisector. Okay, right. So perpendicular bisector. Right. So this is axial line. I will write it, otherwise getting confusion. It is axial line. Next is perpendicular bisector. Right. Let us make a diagram for this one. Let us take now 2 point charges. It is plus q and minus q. Okay. We want to calculate on perpendicular bisector. Where is it? On perpendicular bisector, right? Right. Then see, right. Let us take. So what is now this? This is L separation. This also L. Total value is L. This is now perpendicular bisector. Let us take a point on that. A point on that. Right. Now, first step, imagine a unit positive charge where we want to calculate strength of the field. So imagine here unit positive charge +1. It is +1 at this point. Okay. Now this is a positive charge which repels now this positive charge. Right. Direction will be like this. Okay. Right. That is the direction. Positive charge repelling now positive charge. Coming to here, this negative charge attracts. So force is along the line joining them. That means it is along this line, right? One more vector. Okay. Let me draw it a little bit bigger. Right. So one is like this, other one is like this. Okay, now in this way. If you take now resultant, if you take now resultant, that will be that will be parallel to dipole moment vector like this. Suppose this angle is theta, then this also theta. Angle made by this vector with a horizontal is now theta, right? This is a theta. Okay. And see carefully, this is a theta, then this also same, right? Now what I'm doing here, this is E value because of positive charge, and this is E value because of negative charge. So this is making angle theta with a horizontal. This also makes angle theta with horizontal because these two are now becoming alternate angles, right? These two. So net value will be, and we can see both having same modulus value. Okay, I am writing here E plus is equal to E minus, means modulus values. Okay, I am writing clearly here once again. It is now E plus modulus values are same. Okay, let us call it as E. Then this is now 2e cos theta, or take it as e dash. This is 2e dash cos theta. Let us now calculate what is that net field. Net field will be, it is 2e dash in the place of e dash k, q, k into q1 q2 by r square, q1 q2 by r square. R square how much? Let us take, we are calculating at a distance x from midpoint, or it is r, okay? Then this becomes, distance becomes r square plus l square. That is square root of that becomes distance. We want k q1 q2 by r square. This is r square plus l square, right? Into cos theta. Into cos theta. See, what's the value of cos theta? It is L by again r square plus L square. It is under root, right? So that value becomes now 2 kql upon r square plus L square whole power 3 by 2. Whole power 3 by 2, right? And if you consider, see here how we got this result. Your assumption is L is very small compared to R. Okay, na condition. Same condition if you take here also. L is very small compared to R. So in the place of Q into 2L, I can write P. Remaining is now K P by R cube, right? Kp by R cube. If you want in vector form, I can write E bar equal to minus K into P bar by R cube. If you observe carefully, net field is right side, but momentum vector P bar direction is negative to positive left side. So on perpendicular bisector, direction of E bar is opposite to direction of P bar. And if you compare modulus values, this is a half of this value. This is 2kp by r cube. This is kp by r cube modulus value. Okay. Like this, we can calculate on axial line and on perpendicular bisector. Okay. Now I want to calculate on, it is at a general point. Here we have taken axial line. It is now taken on perpendicular bisector. Okay. Let us take now at a general point. At a general point, let me erase this. Let me erase this. Right. Now we want to calculate at a general point. Right. See carefully. Okay. This is at a general point. At a general point. Let us consider this is now P bar. Okay. We want to calculate at some point that makes angle theta with p bar. That makes angle theta with p bar. This is dipole moment vector. We want to calculate somewhere at this point, distance equal to r. Distance is r. That makes angle theta with p bar. If theta equal to 0, it becomes axial line. If theta is 90, it becomes perpendicular bisector. Okay, right. See here, what I'm doing is I'm taking out two components for this dipole momentum vector. For this p bar, one component is along this direction, that is in this way. That is one is p cos theta. And taking one more normal to that. One more, it is normal to that. That is p sin theta. Okay, right. Now see what happens here. See carefully. Now what I am doing is take these two components as two separate dipole momentum vectors. I am repeating. Take these two components as two separate dipoles. Now this is one dipole. Its momentum is p cos theta. This is one more dipole. Its momentum is p sin theta. Okay, dipole moment. Now for this dipole, this point will be on its axial line. I am repeating. This is now one dipole whose momentum is whose moment is whose dipole moment is p cos theta. For this one, this point will be on its axial line. And coming to for this one, that point will be on its perpendicular bisector. Okay. So for this dipole moment, this will be on its axial line. And for this vector, this point will be on its perpendicular bisector. Then see what I can say here. This may be somewhat confusing. Follow carefully. Well, because of p cos theta means on axial line, field will be along p bar. It is along p bar. Okay. Let us call this as E1. Okay. Let us call it as E1. Next. Because of p sine theta at same point. Okay. This point is now for this one. For this one, it is perpendicular bisector. That is. In that case, E bar is opposite to P bar, right? Like this. It is now, take it as E2. Now resultant will be somewhat like this. This is now resultant. Okay. Now see carefully the value of E1. Value of E1. E1 is 2K P cos theta. I am taking okay, same 2K in the place of P cos theta by RQ. Okay. Coming to E2 value, it is K P sin theta by RQ. If you take now resultant of these two, that means square root of sum of the squares, then see what we get. It is a Kp by RQ square root of 1 plus it is 3 cos square theta. Okay, that is what we are going to get. If they ask what is the angle made by that resultant with E1, suppose this is alpha, then what I can write? Simply E1, E2 are two vectors which are mutually perpendicular. Angle made by the resultant with E1 is given by, I am written directly here only, tan alpha is equal to, it is E2 by E1, right? So E2 by E1 how much? It is 1 by 2 tan theta, right? Yes or no? That is now angle made by resultant with E1. Okay. I hope you got a clarity.